I'm Loretta. I'm gonna attempt to not say a million times today because I noticed I did that in my last video. So here we go. I just watched Terrance Howard's um, address that he did at Oxford. I guess it's Oxford University, and I had heard the news clip of what he had said during the interview on the red carpet. And honestly, the interview on the red carpet kind of perked my interest because I thought it was actually super awesome that he just kind of came out and said exactly how he felt about it and said a lot of stuff that I think didn't make sense to a lot of people. But if you really knew a lot about what's going on in the world, then you obviously knew what he was talking about. And then I was really excited to see actually in this group, which hopefully it'll be posted on, but this specific Facebook group that he does this other Oxford talk with the university. So anyway, he kind of hit upon a bunch of really interesting ideas. And to be honest, I'm very similar in the sense that sort of space and physics and science, I would even say just like quantum mechanics almost, has always been very interesting to me. I didn't study any of that in school. I didn't go to school for that. I think I took one astronomy class in college, and that was like it. I really don't have a like formal education in any of this stuff, but pretty much anything having to do with space is something I get really excited about. And he talked about some stuff, and I just had some really sort of small, big ideas that kind of came to mind, and I wanted to kind of get it in a video and then kind of throw it out there to see what anybody else thinks. And then I have some additional information that I really had been thinking about the other night too as well, which has to do with, it actually has to do more with the Mandela effect, so that's kind of a separate thing. But a lot of this mathematics discussion, I think will really tie into one another. But this is really going to be about the speech that he gave. So one of the really big things that he said that it was funny because he was having people do calculations on their phone, and I couldn't because I was watching on my phone. So I did it after, and I found it really interesting. So he was saying $1 times $1. Mathematically, in mathematics terms, we would actually just say that this is equal to 1. And then, but if you break it down and you go, this is actually 4 quarters. So if we had 4 quarters and we times them by 4 quarters, mathematically what we get is 16 quarters. So this, I'll just put 25 cents. This is 25 cents. And if we think about it logically, like 4 individual coins and 4 individual coins, it's actually a different equation. So mathematically in a calculator, 4 times 4 is 16. 16 quarters is actually equivalent to $4. But if we take $4 and times it by $4, that's not necessarily what we get in the real world. And it's not exactly what we get mathematically correctly. Because if you think about, like I was saying, if you just had a pile of 4 coins and you were trying to times them by 4 coins, logically that doesn't even make sense because you would just be adding them together. You can't take 4 coins and times them by 4 coins and then somehow get in the real world a pile of coins that is greater than 8. So, 4 coins sitting in a pile times 4 coins sitting in a pile actually equals 8 coins, which is only $2. Neither of which, mind you, equal the 1 times 1 equation, which is $1 times $1 equals 1. And this is the same thing. If we had a bill, right, this guy, and we had it sitting next to another bill, and we tried to times it, we couldn't get anything other than 2 bills, essentially. So in reality, this really would equal 2. There are some questions in the discussion about this really just being addition, because in the real world, you can't take $1 and times it by another $1 and like rub them together and somehow get any other number except the number of dollars that you have. And if you were adding, if you just said 1 plus 1, then you have $2. And so he had said something interesting. I forget exactly his wording, but it was almost like multiplication is an exaggerated form of addition. So multiplication is a faster way for us to get the answers that instead of sitting there and adding all of things together. So it does make it really interesting when you start breaking it down into specific numbers, because it really doesn't make sense. Our theoretical math versus real world math doesn't always give you the same answers. Like we were saying, like 4 times 4 in a calculator is 16, but if we're talking about 4 quarters, it doesn't equal $4. There in no way does it equal $4. And in no way does that even equal $1. So where you get 1 times 1 equals 1. And I think what he was kind of implying was, 1 times 1 really in the real world really means 2. It's really interesting when we get to money, because money has all these fractional qualities to it because we break it down in cents. And, a lot of times I think when we're thinking like multiplication, like we want to, we're thinking of other numbers or other problems that are, that we're trying to figure out that have nothing to do with money. But anyway, so he kind of hit upon this, and I had this immediate thought in my mind, and I was like, wow, it almost seems like fractions are the problem. Like this fractional math makes things really complicated. When you're in anything above, he had said something actually really interesting about 2, and it was like 2 squared, or I can't remember if he said the square root of 2, and then you there's a series of dividing it by 2 and then timesing it by its to the power of 2, and you still get it always equals the same number. Like this number is always the same. And he said it's only with 2. If you go greater than 2, if you try to do it with 3 after 6 series of equations, then the number starts changing. And then I think if it's less than 2. So 2 really is the number where it just stabilizes. And so my first thought was, well, if you really think about everything in the universe, everything in creation really comes from what I would refer to as you have divine masculine and divine feminine energy, sort of like it's I don't want to say positive and negative, but the first thought I could even think was just oh yeah, everything in creation has this balance of male female energy. So 2 almost makes sense. 2 is sort of the balancing number of mathematics, and also the balancing number of things in the universe. Like if you're trying to take this number and you're trying to do that, it always kind of equalizes itself. That's sort of the number that keeps everything I would say in the world of numbers, it keeps itself in harmony. And that's because in my perspective, I'm thinking, yeah, there's these two energetic powers, if you will, and those each have their own, would be 1 and 1 and they equal 2. But anyway, besides that, so I go back to this fractional math problem. So I'll just put that off to the side. Fractional math. And so I was thinking, man, this really is interesting, because he had also mentioned something about the CERN particle collider, and he had said something about expressing that there are particle signatures that come from the voids of the flower of life, and that's exactly what people were searching for at CERN when they were colliding together particles, looking for the God particle. Those results that they were looking for were some of these answers that he found in unfolding and opening this flower of life. Now, he didn't go into a lot of the actual particle equations or what the numbers were or anything like that, but he did mention it, so that kind of ties into what I was about to talk about as well, which is the particle collider is really about smashing together particles that are already really small into smaller and smaller and smaller bits. So it's kind of like, I think people say, cracking open the egg, and you're just trying to keep breaking down these things. It's like the fundamental idea of how to figure out what the universe is made of is to really just take the smallest things that we know of and just keep smashing them and smashing them and smashing them, and see what subparticles come rolling out of that, and then figure out how those tiny particles really come together to make the bigger things that then become real physical life manifestations that we have in our world, or physical world things that even we are, able to see on a microscope or at smaller scales with specific kinds of instruments. And I kept thinking, like, so where do we get these units of measurements? Because the first thing I thought of was the atom. The atom is the building block of the universe. They say everything is built and comprised of atoms. That's the sort of smallest particle. For a while that they would say, this is really what the stuff is made of. When molecules are made, they're made of atoms, and then molecules are different combinations of different amounts of atoms, and that's how we get all the different things that we have in our world. And now through research, obviously, they have taken parts of the atom and broken that apart, and you have smaller parts within. I wouldn't say smaller parts, but I know like electrons, protons, neutrons are sort of like energy signatures that are, I think, existing within the atom. I didn't really get too far into that, but basically my first thought was, oh, the atom is the smallest building block. Now, what they tell you is like an atom is 0.1 to 0.5 nanometers. And so then I was like, that's so interesting. Where do we get this measurement from? And then I started thinking about just like the regular, our regular units of measurement. So they say, 1 inch is equal to 1/36 of a yard. It's kind of really interesting how they break it down in definitions on the internet if you ever look. And then a foot, which is 12 inches, is equal to, which was really the average size of a man's foot. This is originally how it came about. And 1 yard was equal to the average size and the average length of a man's belt. And in which case they call girdle. So just really the circumference of a man. So really a lot of this started around these ideas. And I know it goes further back than that, and there are units of measurement. I think I looked up in Egypt had a cubit, and they had different weights. But if we want to just kind of talk not about the far history, but where the common units of measurement, especially with length, and that will define diameters, comes from these units that we use now. And I realize obviously there's a metric system, but for now we're just going to talk in units of parts and yards. So 12 inches, they really went off a man's foot, which is honestly, it's a way to, it's almost like how time is. And I've always said time is really just something man created in a way to organize your everyday life. But if we really understand how the universe works, everything is cyclical, everything's eternal. So there really is no time. But time is a great way for us to try to break down our life into these segmented frames of reference so that we can organize what we're doing and how we're doing it. But it's really not real, like, is the best way to put it. It's not really not real. So the same thing, I think, kind of almost applies to this. There was a time when it became efficient for man to create units of measurement. So they wanted something, or they needed to build something, and it had to be this far away, or that, and they needed to measure. And then they started using, obviously, there was measurements, like I said, before this. Civilizations before this obviously used their own, but let's just say we're picking up from here. They started saying, oh, well, I measure things a lot by walking. I have to use a frame of reference. And right now, my frame of reference is me. My human body, that's the frame of reference. I'm living in a world, and I have no idea how big the world is. Let's say, like, people back then when this is coming up, like, they really didn't understand. They were still doing so much exploring during that time, really figuring out the size of your life and your body in perspective to the bigger whole of this planet or the country or the region that you were living in. So at that time, it made sense to average everything off of your singular perspective, which was you, your human body. Now, going along with that, they're saying like, okay, this is this, and then an average yard is the length of the man's belt. That's convenient because during this time, a lot of people had belts. So instead of having to figure everything out by foot, and obviously maybe there was discrepancies with people's feet, they used a man's belt. And then obviously at some point it became sort of a signified amount. Obviously everybody's belly is different amounts, but kind of came into this, the average of 3 feet, 3 feet or 1 yard. So anyway, what I'm trying to point out is these units of measurements, which we still use today, really had a point of reference that was you, or the human. This was the point of reference. Oh no. Okay, sorry. Point of reference is human. And what we've kind of done through a lot of our, I'm going to try to fix this, scientific research, is we've just continued to use this unit of measurement as our point of reference. Everything in our world in relation to our size, which for a very long time obviously made a lot of sense. How else are you going to measure anything else in the world except to the perspective in which you're looking at it? Now when we come to atoms, which are obviously way smaller than you or any point of reference on your body that you can visibly see, atoms are molecules are existing in this world that is invisible to the naked eye. You have to have a machine to measure down, but the easiest way to describe this when it came about was, why don't I take this unit of measurement, me, and let me break this down. So let me say that this atom is this fraction. So this is representational. This is a fraction of us, the human. The human. This is how this unit of measurement is evaluated. And when we're going down even further than that, when we're smashing apart atoms and we're looking at quarks, or I don't even know all the names, but just any of the particles that even make up an atom, when we start having these experiments like at CERN and we're smashing things apart and we realize that there are even smaller bits of the atom, so we go like this. So we're like, here's the atom, and then there's like whatever, these little parts that make up the atom. Then what we do is we say, let me take this number, and this becomes whatever fraction of 0.1 to 0.5 nanometers. So I'm going, this is really complicated, not only for mathematical terms, but it's just complicated because fractions are really tricky, because any number or anything can simply infinitely be broken down into smaller and smaller pieces. It's like the enigma of saying, like, I don't know if you've ever seen that thing, but you're like, I just keep drawing lines, and like you can just keep drawing lines, and theoretically you can just get smaller and smaller and smaller, and there is no stopping because of the way that fractions work, because you're putting 1 over a number, and there are endless amounts of numbers, there are endless amounts of smaller pieces that something can be, which creates kind of a conundrum in the thinking. And I think that almost creates this vortex of trying to understand, how does everything become smaller and smaller and smaller, and what is the smallest part, and how can we go smaller? And theoretically, we could just keep going smaller and smaller and smaller. And not to say that it is, but just on paper, yeah, of course, we could just take this particle and smash it apart, smash it apart, smash it apart. And the idea behind the numbers is that it would just keep going, which is kind of, sort of unbelievable in a sense. But anyway, so this, whatever. And then I was thinking in my brain, just randomly after this speech, I was like, whoa, what about this though? It's so complicated dealing with fractions, and we can see the problem with fractional math here. This fraction, 0.25, or if you say, 0.25 times, and I think I did it with dimes too, which is like, if you have 10 dimes times 10 dimes, what does this equal? And if you put it in a calculator, 10 dimes times 10 dimes, you get 1 cent. 1 cent, which makes no sense. So theoretically, the theoretical math, 0.10 times 0.10 equals 0.01, which is absolutely incorrect. If you have 10 dimes and you're timesing them by 10 dimes, you do not get 1 cent. And to be honest, 10 dimes times 10 dimes doesn't equal 100 either. If you were to try to just say, I have a total of 10 and you're not taking the fraction, you're just like, I have 10 coins, so I have 10 units, and I'm going to times them by these 10 units, these other 10 coins, I would theoretically get 100 units. So this is like, if this is a unit, and this is a unit, but you don't get 100 units. You don't. If you have a pile of, 10 dimes, and you times it, I think that's 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8. I'll just get rid of these two so everyone's confused. The number of dimes you get is really, it is in a way just addition, but you only get 20 dimes. So these fractional equations are complicating math in a way that doesn't even make sense. It kind of creates its own conundrum. So I was thinking, this made sense, man making these units of measurement, because at this frame of reference, they didn't know about smaller things. Or let's say that when they made these things, they weren't, the frame of reference was really people. And especially even in times like later than that, I'm sure when people were building during the Roman times or Egyptian times, units of measurements were really based off of the visible world. So what could I see? What is the smallest piece of something that I can see, and what is the biggest piece of something I can see? So if you're saying, oh, this pebble, it's like, a lot of times you would, like, back in the day, they'd probably put it in your hand and you'd be like, oh, this is like 1/100th of I could fit 100 of these in my hand. So your frame of reference was always the human body. So now we're in this world where we completely have proven that there is this sub-world that exists that is invisible to the naked eye, but is essentially there. And so all of these numbers, instead of existing as fractions of us, I was like, wouldn't it make more sense if all of a sudden you're like, oh man, I just discovered this, and it's like 1/10 of us, but we'll just take the atom for instance, and instead of saying that the atom is 0.1 or 0.05 nanometers, we're like, this is the smallest building block, right? This is the smallest building block. What if we set this to 1, right? So instead of using this as a frame of reference to measure everything in the universe, when we know that there's an infinite scale that exists that is smaller than us, and there's infinite scale that exists larger than us, it's like, doesn't it make more mathematical sense to, once we find the smallest particle, that particle is set to 1. That is the smallest unit of measurement that exists to us. And then once that number becomes 1, everything that is built off of that is a multiplication and or addition, I actually didn't think about, of what this is. So even if we found out, oh, there's however many of these in an atom, right? So you wouldn't say that these are 1/7 the size of this. You would now set this number then becomes 1. And then an atom is 7 of these. So whatever this subparticle is that makes up an atom, instead of saying that this is 1/7, you set this to 1, and now you're like, oh, well, atoms are actually 7, because they are comprised of 7 of these. So that kind of makes way more sense. It makes the math way less complicated, because we're saying, all right, if everything in the world is built off atoms, and now we're finding out that all atoms are built off this, then an atom is really made up of 7 parts. This is 7 parts, right? this is not 1/7 of an atom. Like, that almost is making it sound like it is a piece of itself, of its whole or something. You know what I'm saying? Like, you're saying, like, oh, this is like, it's almost like if you had like a slice of pie and there was like 7 slices or something, and you're like, oh, this is 1/7. But it's not a slice of itself. 1/7 makes sense when it's a part of a whole. So this is part of a whole. But if we break something down and we realize that this particle in and of itself is complete, it is a singular complete part of something that can be used to build something else. So this isn't a part of a whole. This little particle, this is a whole that is then used to create things by having other particles that are the same as it built alongside it. This is what we're talking about when we use atoms to create molecules. We don't say like an atom is a fractional piece of a molecule. We say atoms are atoms, and atoms combine to make molecules. And now these, whatever nanoparticles that make up atoms, I don't even know if there's a name for these or if they exist, but these combine to make a whole. So we set that standard at 1. And I'm not saying that it makes sense to go around and reset like an inch to however many pieces of particles, or maybe it does. I don't know. Like, I know that's really complicated, but I think if we're talking about physics, and I think if we're talking about math on a scale that's anything less than what we visibly see to our naked eye in our physical world, it becomes part of this other dimensional mathematical landscape that is in and of itself functional with a different set standard of math, which is to not compare it to something that exists in the physical world, and to not have a unit of measurement to describe it that's in comparison to what I see in the physical world. That this whole world, and I want to say, this realm of not seeing, this is like its own dimension. This is its own dimension that exists, invisible to the naked eye. That's not, that's, let's just, if we say it that way, then math in this dimension can have a different set standard. It doesn't have to be compared to things in a dimension that exists that, I understand that when you keep going up, it can. And to be honest, maybe it does make sense. What if you take the smallest particle and you set that at 1, and then every other measure off of it, it becomes a multiplication of that, or even just, if you want to say multiplication works because that's faster because the particles are so small, but I'm just thinking this could get rid of some of the complications that come in with fractional math. And to be honest, money, I know that this is like stuff that gets discussed in like zeitgeist, I think. This is like why we shouldn't have change. Like, this is how money disappears. This is how little nano cents of money that we have, or money that's being made, or money that's being generated go places, because in a computer 10 cents times 10 cents equals only 1 cent. But that doesn't make sense. So when a computer is doing math, business transactions, stock exchange transactions, and there are cents involved, how does that, are there like algorithm math equations that rectify this difference from our reality, which you can't even say, well, I have 10 units of dimes and I have 10 units of dimes, and that equals 100 units, because that doesn't make sense either. So then we're saying, well, if you have a math transaction and we're talking about timesing this by this, where do all these, rectifications come in? And we know in the stock exchange that there are there's like penny stock, isn't there like penny stocks? And there are stocks that are not equals, like equal dollar amounts. And how does that work? Like, how are we, because the stock exchange requires us to also take in consideration these 2 decimal points after for these monetary exchanges, how are these equations amended when a computer is doing math? How does this make sense when this happens in a generated electrical forum versus like if you were standing there with a guy and you said, well, I have my 10 cents and time isn't above at 10 cents. Like, you both know, sure as shit, there's no more than 20 cents. So, or like 20 dimes. So, either way, it does make it really complicated in understanding, sorry, I'll just move that, understanding how this works. And this is a lot of the reason I think why people went through this whole period of time and saying that cents, we should just get rid of them. This is a really easy way for little tiny fractional parts of money, which in a way does exist. It ends up going somewhere, and nobody really is asking questions like, where is it all going? Where do these cents go, and how do these equations get amended? And I don't know, maybe somebody will post a video and be like, yeah, they have algorithms that like fix all that. But it's really funny that we have to create other mathematical equations to correct what essentially is incorrect math. That makes no sense, actually. So instead, it's far less work to simply have a mathematical system that doesn't require things to be amended like this, or other equations to be added in order to make sure that the math is done correctly. And so it makes sense. And people are like, oh yeah, but there's like things in our world, like what if I want to buy a piece of candy and it's only a quarter? It's like, what if nothing in the country, let's just say, or whatever, was less than a dollar? Let's just, if we confine it to the United States, it's like maybe all the transactions were all these like empty cents or like other cents that we don't know where they are. Maybe somehow that would come back, find its way back into the economy instead of, I feel like it's siphoning into people's individual pockets somewhere. And without being able to track that, then, if we got rid of that and then people were held accountable for the full value of every transaction that they made, maybe we would find that a lot of that money would regenerate itself back into the normal part of the economy instead of finding its way and seeping its way into individual privatized hands. That's a whole different discussion in itself, but I just wanted to point out that this fractional math that exists as part of our whole monetary system, so it's in our everyday lives, that, it's more than just money, but it is abundantly apparent, especially now when we're coming into the study of quantum physics and quantum mechanics, and we're talking about, energetic fields that exist and people trying to find the God particle, and literally talking, people's coming into the understanding of multiple dimensionality and what that is and what exists in what dimension and how energy travels. But this kind of ties into the other video that I had too about, time threads, and like, it's exactly like what Terrance Howard said. Energy, the first thing we learn in science is that it can't be created or destroyed. So, it's, I guess that's kind of irrelevant to this, but, this is all these fractional things that start making things complicated. Like, that energy has to go somewhere too. And if we really start breaking it down, it seems like it makes a lot more sense that, at least in this world that we technically don't exist in yet, because it's on this, or I shouldn't say technically don't exist in yet, but if we are zooming in on this world of particles, nanoparticles, and everything that is invisible to the eye, technically in that dimension, our structure is not even, when I say doesn't exist, it's undetectable. It's not detectable at that level. So if you're an atom and you're existing in the world of an atom, you don't know that there's a human, because that structure is so beyond the perception that's available within that dimension that you don't exist to them in that dimension, which means that using any kind of math outside that dimension to describe how big you are, like if you're an atom, you'd be like, I'm 0.5 nanometers. Like, they don't know what that is. They don't know what a nanometer is. An atom would be like, I'm 7, and the parts that make up the atom, and they'd be like, we're 1. Like, you can only apply this kind of other mathematical system to this because all of these measurements exist in a construct in a dimension that is outside the parameters of what is sort of detectable as in, to this sort of scale. I guess if that makes sense. It's kind of a complicated way to say it, but so that was really it. I kind of just needed to get that out. I watched that video and I just like had this spark and I was like, yo, what if an atom was just one? And I was like, doesn't that make more sense? Like, why are we breaking everything down into smaller and smaller parts? And when we talk about physics, it's just like that infinity conundrum, which is also, just that everything gets smaller and smaller and smaller and smaller, and it can get infinitely bigger as well. But it creates a lot of places where you're just like, does that make sense? That doesn't make sense. Or this equation makes sense, and it doesn't really make sense over here. And, 1 times 1 is 1, but it can be 16, but it can also be 8, which is also $2 or $4. It's like, math shouldn't be that complicated. And, we shouldn't have answers that make sense, in one perspective and then don't make sense in another perspective that makes it really complicated when we are literally building our world with math. We're building our world on an economy that is built with math. We're building our world physically with buildings and streets and structures that are built off of math equations as well. And, our lives, our bodies are built off of, divine math that makes up the structures that we are. And so how do we amend these different realities or these different, dimensional perspectives in a way that makes sense? And, we're not, I actually don't even know that I believe in particle colliding and smashing things together like that. Like, I don't know that that's the best way to understand the greater part of what we are, but, to each his own. Everybody has a different way of figuring out, their place in the universe. And but if they did, they might find it useful to change the system to one, or just, whatever that smallest particle is, that we know is a whole in and of itself that other things are built off of by adding more of those individual pieces together. Whatever that particle is, that particle needs to be one. And then everything above it needs to be 1 times whatever. And then once you get to the physical world, once we blast out of this not visible to the naked eye, then we can start measuring things back into our normal unit of measurement, which is, by our perspective, 1 inch or whatever that. And we would say, 1 inch is like 70 billion, like, multimeters of atoms or whatever it is. We should have a greater understanding that we are not the one. This is what I coined some kind of term for it, and I already, like, it's like the integer of 1 or something. It's like the universe. I forget. Like, I'll think of something more catchy at a later date. But that everything, if we are trying to figure out how our universe is built by figuring out what the smallest particle is, and once we get there, and once we find that smallest building block, that building block needs to be the measurement of 1, and everything else needs to be built off of it. Because in reality, that's how it is. They're not portions, pieces, or fractions of us. We are a combination of them. So that smallest particle, literally, everything is built off of that. You build that makes something. You have another one, it builds itself, and that makes something, and those come together, and those make something. So that's 1. And everything else up is a multiplication of that number. I just want to add that I just was thinking about this for a second, and there is like a diminishing quality that happens to everything when we start breaking down things as fractions of something else. If we know that this smallest thing is used to build other stuff, if we get multiple of these items and they come together and that creates this, and then we get multiple of those items and those combine to create something else, it's the idea that the whole structure of everything is really, it's an addition, it's a building of other items. It's a combination. Instead of kind of diminishing everything to just be kind of like little pieces and parts of something else. It's just kind of the same thing if you are someone who is trying to, I always say, like, live offensively. I'm trying to be someone who isn't trying to draw the line in the sand, isn't trying to always be like kind of like on edge that something bad is going to happen. It's kind of like always living that you're going to get the best in people and that you're going to have good situations. And you sort of, to me, it's like living offensively instead of living defensively, is always drawing the lines and always being concerned and always having to protect yourself and always having to be safe. And it's, while there's like a certain level, I think, of, smart living, that there's a difference between the two, and there's nothing wrong with either one, but it's the same analogy as like the glass half empty or half full. It's the same state of being, but it's just two different perspectives, and one is kind of like this negative perspective, this diminished quality of life, and one is I don't know, it's like opposite word, but one is this more abundant sort of look at life. So instead, it kind of exists also in this world of particles that we're talking about, that really the whole world and the universe is built off of these particles, and particles that we haven't even seen, or particles that we don't even know about because we haven't gotten to the point of being able to observe those. But that instead of giving the universe this diminished quality, that things are built off of fractional pieces of something else, that the universe and everything is built off of additions of everything else, or in some sense multiplications of everything else. It has this abundant quality to it, which is the smallest thing in life that is used to create the biggest things in the universe. And so it's a completely opposite way to look at everything. It sort of has, to me, a more positive aspect to it. Not that I think it's important to really think negative or positive, but it's really about the quality of not trying to think that everything is like this microscopic, like I said, like sort of diminished part of some other piece of being, but that everything that we know of and is a combination of other parts. It kind of gives us a better idea of the integrated quality that we have with everything else, that we are essentially built of the same stuff that is nothing, that is existent in the molecules in this air that you can't even see, that's existent in things in outer space, that's existent in water and plant and trees and animals. It's all the elements that the universe is comprised of, is really connected to these nanoparticles, to these smallest pieces and these smallest parts. And when you call these things the ones of the universe, then everything is a multiple quality of that. You can start to see how, and I was kind of talking in my other video about these time threads and the space-time fabric, that these are the sort of strands that really connect everything at this microscopic level that we can't see. So these nanoparticles, these are like the base strands of everything else that everything else is going to get built off of. And if you watch the other video, it's really about how time threads, and you're this weaver of this space-time fabric, and we all are. Everything is weaving part of this space-time fabric that we exist in. And when we're manifesting, and even when we're not, we're basically pulling all these different threads of life to us, and it's these threads that combine, or we're calling strands, and these strands combine to make threads sometimes, and then we use these individual strands and we use these threads to weave part of the space-time fabric, and everybody and everything around us is doing the same thing at the same time. But these individual particles, these what I like to call the baseline, these are like the base strands. If you were to take the threads and the yarns and all of those, that portion that we're using to kind of weave our reality, weave this space-time fabric that we exist in, these individual strands are the ones that just run in and out of everything. And so everything is kind of built off that. So you have these little microscopic, tiny strands of energetic life that run through everything else, and then there are bigger strands that are created from combinations of those strands, and then bigger threads that are created from combinations of that strand and other strands from other places, and these threads combine to make yarns and like different, I'm just saying, just like different scales of these kinds of threads of life, and that is what really creates what we call this fabric that we're weaving, that everything else is weaving, that is the substructure, base structure, that it is the structure of everything around us, whether we see it or whether we don't. So rather than to give it this diminished quality, which is like, it's almost like taking the idea that we have this fabric and then these pieces are somehow like these little frayed, like these other little, like I'm taking this thread and I'm breaking it down and breaking it down and breaking it down, and then you kind of just have like this in your mind, you're thinking like, oh, it's like this, the middle tiny strand to this now frayed thread that I have, and it's not that. It's like the complete opposite. It's like this strand that gets this momentum by having all these other strands wrap around it, and then this is like this solid thread or rope or twine or yarn or however you want to describe it, that now is being used to weave a multiplicity of infinite different things. So I think it's just really important for us to get behind the idea that we build off of these things, and that this substructure isn't this diminished part of our existence. It's not some diminished fraction of what we have. It is the base of what we are. So I just want to get that. I hope Terrance Howard gets to see this video at some point, because I think it makes a lot of sense. I'd love to pick his brain. Please question, comment, email me if you have anything to say about this. I'm sure there's going to be like, quantum mechanics or physicists that might have something to say about it. I have no idea at all if anybody has ever spoken about this idea, but it makes a whole lot of sense to me, and I'm just throwing it out there and wondering if it makes sense to anybody else.